Hi everyone. In previous video, we looked at how to find the shortest path in a directed graph using the Dijkstra algorithm. In this video, we'll try to solve another problem trying to find the shortest path in an undirected graph using the Dijkstra algorithm. Okay, let's try to solve this problem using the Dijkstra algorithm. As this is an undirected graph, that means you can go from 0 to 1, even you can come back from 1 to 0. Our starting node is 0, and the cost of going to our starting node is 0, obviously, because you're already present there. And just like the previous video, we're going to use this table. First column represents all the visited vertex on nodes. This will be our visited nodes or vertex, and all the other columns are representing the nodes, all other nodes like 0, 1, 2, 3, 4, all other nodes. And the row is going to be representing the cost of visiting these nodes. So if we are starting from 0, that means all other nodes we still haven't discovered. So going to those nodes, or the cost of going to those nodes, is always going to be infinity. So going to 0, the cost is 0, and all other nodes is going to be infinity. So we're going to fill our table just like this. And the visited vertex is 0. From 0, we can visit 1, we can visit 3, we can visit 4. If we visit 1, the cost is 3. So let's update in our graph. The new cost of going to 1 is 3, and the 1 is discovered, and the cost is 3, not infinity. From 0, we can go to 3, and the cost of going to 3 is 8. So 3 is found, the cost is 8, not infinity. So we're going to update in our table also. From 0 to 4, the cost of going to 4 is 7. Again, let's put it in our table. So, and 2, we still haven't discovered, so it's going to be infinite. Now, as I previously mentioned, Dijkstra follows greedy algorithm principle, which means always pick the best option. And among this number, which one is the best option? Obviously going to node 1. So we're going to visit node 1. We're currently at node 1. From 1, let's go to 2. First, let's go to 2. And the cost of going to 2 is going to be 1. And cost of going from 0 to 1 is 3. So the total cost is going to be 4 for visiting 2. So 2 is found and the new cost is 4. So we're going to update in the table. And from 1, we can visit 3, and the cost is 4. So 4 plus 3 is 7. The new cost is 7, which is better than our previous. So we're going to update in our table. Now, can we visit any other node from 1? No, we cannot. All the possible discovered nodes are already discovered. Let's put 7 down. So which is the best possible route? Definitely going to 2. Next, we're going to visit 2. And previously we visited 1. Now we are at 2. So from 2, we can go to 3. Even we can go back to 1, but which we are not going to do because that is not what we want. We want to discover the best possible path, right? So from 2, we can go to 3. And the cost of going to 3 is 2. And the cost of going to 2 is 4. So 4 plus 2, which is 6. Again, another improvement for finding 3. So we're going to update in our table the 6. And between these two numbers, obviously, we're going to visit 3. This is more efficient. So we'll be visiting 3. So we're currently at 3. From 3, we can visit 4. Cost of going to 3 is 6. And from 3 going to 4 is 3, which is total is 9, which is bigger than 7. So we're not going to pick. Now we're going to be visiting 4. So, and this is our last node. Now let's try to fill the second table. From 0, let's try to go to 1, 2, 3, and 4. All other nodes, let's try to visit them. And we're going to also update the found by and the final result and the cost. We can already update the cost, but let's get along. Suppose from 0, we want to visit 4. From 0, we want to visit 4. What you want to do in the final result, let's put 4. Okay, first we're going to put 4, and we'll put our one arrow in the visited vertex of 4, which is in here, and the cost is 7. Now we're going to put the cost 7 in the table. Now from here, from the arrow, we're going to go one row up, move one row up, and we're going to compare the two number. If it is equal, then we're going to go one row up again and compare again these two number. Is it equal again? So go up again, compare. Is it equal again? Yes, it's equal again. So go one row up. Is the value changes? Now the value changes. If the value changes, then from here we're going to move to the next visited vertex. In this row, the visited vertex is 0. Now we're going to also put that in our final result. So from 0, we can go to 4. Even we can like justify our answer using the graph. So from 0, we want to go to 4, and the cost is 7. The cost is 7. From 0, we want to go to 3. Okay? From 0, we want to visit 3. Again, put your arrow in the table of the visited vertex 3. This is our visited vertex 3. And we're also going to update the cost 6. The cost is 6. As you can see, the cost is 6 in here. And we're also going to write the 3. And after this, we're just going to go one row up and compare the number. If the number is equal, move one row up. But in this case, the number is not equal. So we're going to find the next possible visited vertex, which is 2. So we're going to also put that in the table. 2 we have visited. So follow the same procedure. Go one row up again and compare the number. It's infinite, and the 4 is definitely not equal. So we're going to visit the next possible visited vertex. In this case, in this row, the next possible visited vertex is 1. So we're going to update in the table below. Now follow the same procedure. Go one row up. Yeah, one row up. Number changes, yes. Next possible visited vertex, which is 0. Let's update in the table. From 0, we go to 1, then we go to 2, then we go to 3, and the total cost is 6. Again, we can justify our answer from the graph. From 0, we're going to visit 1, and the cost is going to be 3. From 1, we're going to visit 2, and the cost is going to be 1. So 3 plus 1. From 2, we're going to go to 3, and the cost is going to be 2. So 2, this is 6, this is our number, and this is our number, even this is our number. So all of them are like lining up together. Let's try one more. From 0, now let's try to visit 2. Let's put 2 in our final result, and let's put our arrow in the table. Now the cost we can see is 4. Let's put the cost in our cost column. And from this table, let's go one row up. The value changes. So let's find the next possible future vertex, which is 1. Let's put 1 in the table. Then go one row up again. The value again changes. Let's find the next possible future vertex, which is 0. Let's put 0. So from 0, we have to go to 1. Then we have to go to 2. And the cost is going to be 4. Again, you can justify our answer from the table. So first we're at 0. From 0, we have to go to 1, and the cost of going to 1 is 3. From 1, we can go to 2, and the cost of going to 1 is 1. So the total cost is 4. The total cost is 4. Now you can solve from 0 to 1 easily. From this, you can directly go from 0 to 1, and the cost of going to 1 is 3.